Welcome students. Today we shall discuss an interesting paradox involving the irrational number pi. We shall see in this short video how looking into things in an ordinary way might be entirely different from looking into the same thing in a mathematical point of view. So let us start the video. Now this is what? This is a semicircle based upon this straight line. Now let us do one thing. Suppose we are trying to draw multiple number of semicircles inside this bigger semicircle upon the same straight line. What will happen? Let us see. Suppose this is the center. Initially, we draw two semicircles. Then again, we draw more semicircles inside this. Now again more. And so on. Now let us observe what is happening. The more we are increasing the number of semicircles inside the bigger semicircle, the semicircles are more or less tending to coincide with what? With this straight line, with this same straight line which was actually holding the bigger semicircle. So in other words, if we say, if we increase the number of semicircles inside the bigger semicircle, like it tends to infinity, then the semicircle's view will more or less coincide with the straight line. So this is an ordinary observation which we have made. Now for the time being, let us keep aside the ordinary observation which we had made. That is, if we increase the number of semicircles, suppose the number of semicircles tends to infinite within this semicircle, then the semicircles more or less coincides with this straight line. Let us keep that observation aside for the time being. Instead, let us dwell into the mathematical part of it. Now, if this is a semicircle, suppose with radius r, then the diameter will be 2r. And what will be the length of this arc? Half of the circumference of the circle. Now for radius r, circumference of a circle is 2 pi r. Okay, then half of 2 pi r will be pi r. So the length of this arc will be pi r. Okay, let us write over here. Length will be pi r. Okay, which length? This length. Now, what will happen if we divide? If this is r, then half of it will be r by 2. Half of it will be r by 2. Then what will be the circumference of this arc? Pi into this radius. So pi into r by 2. So total this plus this, pi r by 2, pi r by 2. So twice pi r by 2. That is again equal to pi r. Okay. Now what will happen if we further divide? Now length of this radius, this part, this radius will be, if this is r, this is r by 2, this is r, this is r by 2, this is r by 4. Okay, so this will be pi into r by 4. Similarly, this will be pi into r by 4, pi into r by 4, pi into r by 4. So, if we add up all this, it will be 4 times pi into r by 4. That is equal to pi r. Again, so very interesting observation is coming up over here. That is, if this is pi r, and if we divide the semicircles within the bigger semicircle, even then the total circumference of the inside semicircles will also sum up to be pi r. So if we keep this in mind, and if we increase the number of subdivisions, that means length of this plus this plus this plus this plus this plus this plus this, that will also sum up to be pi r. Now let us continue this process infinite number of times. So what will happen? These semicircles will be small semicircles over here within. However small, the length of all the smaller semicircles adding up, it will be pi r. Now let us bring back the ordinary observation which we had made. In the ordinary observation, we saw that the length of this small semicircles, if we increase the process infinite number of times, it more or less coincides with what? Coincides with this straight line. Now, if we bring that observation into this mathematical analysis, mathematical part, what tremendous error will happen? Let us see. So, if we bring that into it, what happens? Now, according to the mathematical part, however small the semicircles might be, the sum of the circumferences will add up to be pi r. And in the ordinary observations, the sum is tending towards the length of this straight line. What will be the length of this straight line? If this is r, the length of this straight line will be 2r. So pi r tends to 2r. Now, cancelling r in both sides, pi is tending to 2. How come? The value of pi, even though pi is an irrational number, the approximate value of pi is 3.14. We could have said it tends to 3, it tends to 3.147, something like that. But pi is tending to 2 according to this. This is what will happen if we mix up our ordinary observation with the mathematical part. So my dear friends, in this short video, we have seen that how ordinary visualizations might be entirely different from their mathematical counterpart. And if we try to mix it, this might produce devastating results. If you have liked this video, then please like, share, follow and subscribe my page and channel. Till then, goodbye.